Good morning to all. Today we are going to discuss chapter number 4 of our NCERT book, that is Carbon and its Compound. So firstly we are going to discuss some basic properties of carbon. The first property is carbon is an element. The second property is carbon is a non-metal. And the third property is atomic number of carbon is 6. And if I talk about the atomic mass of carbon is 12. And if I talk about the electronic configuration, then carbon has electronic configuration of 2 and 4. Now, what does that indicate? It means in case of carbon atom, the inner shell has 2 electrons, and in case of outer shell, carbon is having 4 electrons. So if I talk about the octet, so is the octet of carbon is complete? The answer is no, because what octet rule says, as per octet rule, there should be 8 electrons. There should be 8 electrons in the outermost shell. And if I talk about the case of carbon, carbon is having 1, 2, 3 and 4 electrons in its outermost shell. So it means the octet of carbon is not complete. Carbon requires 4 more electrons in order to complete its octet. So the question is, what kind of bond is formed by carbon? Let's see. Now we are going to discuss what kind of bond is formed by carbon. The thing is, carbon always forms covalent bond. And before discussing that, we need to know what are different kind of bonds. We are having 2 kinds of bond. The first one is ionic bond and the second one is covalent bond. Firstly, we are going to discuss ionic bonds. So what are ionic bonds? As the name itself indicates, ionic, it means there is a formation of ions. So if I talk about the example of ionic bond, the very common example is of our NaCl. It is sodium chloride. Sodium is a metal and its atomic number is 11. If I talk about its electronic configuration, then the electronic configuration of sodium is 281. It means in outermost shell, sodium is having 1 electron. And if I talk about the electronic configuration of chlorine, chlorine is what? Chlorine is a non-metal. And the atomic number of chlorine is 17. And the electronic configuration of fluorine is 287. It means in the case of chlorine, the outermost shell has 7 electrons. And as per octet rule, there should be 8 electrons in outermost shell. So how our compound is going to get stable? How our atoms achieve stability? Let's see. This is the example of NaCl. We know that sodium is a metal and in the outermost shell, sodium is having 1 electron. Now, to satisfy octet rule, sodium either has to what? Gain 7 more electrons, or sodium can lose 1 electron. Now, which one is the favorable one? Sodium can lose 1 electron easily because it is very hard to gain 7 electron. Now, if sodium is losing 1 electron, here in the outermost shell of sodium, the 1 electron is moving toward the chlorine. If sodium is losing 1 electron, then sodium left with 2, 8. It means in the outermost shell, the sodium is having 8 electrons. So our octet rule is satisfied here. To accomplish the 8 electron, sodium is losing 1 electron and gaining stability. And now if I talk about chlorine, the electronic configuration of chlorine indicates that chlorine needs 1 more electron to complete its octet, because in the outermost shell of chlorine it is having 7 electron. Now to achieve the octet, sodium either can lose 7 electrons or chlorine either can gain 1 electron. So which one is the easiest task? Gain of 1 electron is far easy. So chlorine will gain 1 electron from the sodium, that is the electron ejected by sodium, and the bond formed will be ionic. Here sodium is losing 1 electron, -1. So it come up with sodium positive. And if I talk about chlorine, chlorine is gaining 1 electron and it come up with chlorine negative. So the atom having positive charge is called cation and the atom having negative charge is called anion. And there will be attraction between sodium positive and chlorine negative. So this kind of bonding where the interaction occurs is called ionic bond. So NaCl is forming ionic bond. Now let's talk about the bonding in case of carbon. Now we are going to discuss covalent bond. Okay, firstly we are going to discuss the example of CH4, that is methane. And methane has 1 carbon and 4 hydrogen. If I talk about the electronic configuration of carbon, we know that carbon is having 2 electrons in the inner shell and 4 electrons in the outermost shell. And if I talk about the case of hydrogen, hydrogen is having only 1 electron. It means hydrogen has to complete his doublet. In doublet, it is the accommodation of 2 electrons in the outermost shell. Now let's see what kind of bond is formed by carbon. Here, this is the bonding in case of CH4. If we look at the figure, in the center there is a nucleus and this is the inner shell having 2 electrons. In the outermost shell, carbon is having 1 electron of its own. And if I talk about hydrogen, each hydrogen has his own electron. Now what's happening? Each hydrogen is sharing its electron with the carbon. We are having 4 hydrogens. It means 4 electrons are shared with the carbon. So carbon is having 4 electrons of its own, and by the sharing, carbon is also getting 4 electrons. So in total, carbon get 8 electrons. So the octet of carbon is completed. Now, if I talk about the hydrogen, in case of hydrogen, hydrogen is having 1 electron of its own. And here, each hydrogen is getting 1 electron from the carbon. So by that, hydrogen is completing its duplet. Here, hydrogen is having 2 electrons, 2 electrons, 2 electrons. In that case, 1 electron is of the hydrogen and the other electron is gained by hydrogen from the carbon by sharing. So covalent bonds are those which are formed by sharing. In this case, carbon has completed its octet by sharing 4 electrons, that is from the 4 hydrogen atoms. And on the other hand, hydrogen has completed its duplet by gaining 1 electron from the carbon. So this is all about covalent bond. Covalent bonds are those which are formed by sharing of electrons, as we have discussed in the case of CH4. Now, let's discuss some examples. Examples of covalent bonded molecule. The first example that we are going to discuss is of the hydrogen molecule. If I talk about hydrogen, the symbol that we use for hydrogen is H. And we know hydrogen is always present in diatomic form, H2. We know that hydrogen is having 1 electron in its outermost shell. And hydrogen has to complete its duplet. So, if I take 2 hydrogen and this hydrogen will share the electron of this hydrogen. And in turn, this hydrogen will share the electron of another hydrogen. So, this is the bond formed by hydrogen. Here, so hydrogen is having single bond. Now, what does that indicate? It means hydrogen has completed its duplet by the sharing of electron with the other hydrogen atom, as shown in figure. Here, if I talk about the figure, the hydrogen is having 1 electron. And this is another hydrogen which is having 1 electron. And by clubbing, they are forming H2, where both of the electrons are shared by both of the atoms of hydrogen. So this is the covalent bonding in case of hydrogen molecule. Now let's move to the another example, that is oxygen molecule. Now if I talk about oxygen molecule, oxygen has double bond. It means oxygen atom will form double bond with another oxygen atom. Now let's talk about the formation of double bond. If I talk about the atomic number of oxygen is 8. And if I talk about the electronic configuration, the electronic configuration for oxygen is 2 and 6. It means oxygen has 2 electrons in the inner shell and 6 electrons in the outermost shell. And again, if I talk about the octet rule, oxygen requires 2 more electrons in order to complete its octet. In outermost shell, oxygen is having 6 electrons. When oxygen get 2 electrons, then there will be total of 8 electrons. So how oxygen is managing to have 2 electrons? Let's see. Here in this diagram, the outer electrons of oxygen are represented. 1, 2, 3, 4, 5, 6. And in the case of other oxygen atom, there is also 6 electrons. Now, what oxygen will do? Oxygen will share 2 electrons of the neighboring atom. Same, this oxygen will do that it will also share the 2 electrons of its neighboring atom. And collectively, each oxygen atom is having 8 electrons by the sharing of 2 electrons from the neighboring atom. Now the oxygen is sharing 2 electrons from the other atom. If the oxygen is sharing 2 electrons in that way, what happens? In that way, say this is shared by oxygen atom and this is shared by oxygen atom, and here the bond will be double bond. In single bond there will be 2 electrons and in double bond there will be 4 electrons. It simply means in case of a bond there is the involvement of 2 electrons. Here that is the case of the oxygen molecule where the double bonds are forming. Now let's move to our next example. Our next example is of nitrogen molecule. Now if I talk about nitrogen molecule, it may form triple bond. Let's talk about the atomic number. The atomic number of nitrogen is 7 and electronic configuration of nitrogen is 2, 5. It means in K shell nitrogen is having 2 electrons and in L shell nitrogen is having 5 electrons. Now let's talk about the bonding, how the bonds are forming in case of nitrogen. If I look at the structure of our atom nitrogen, in the inner shell there are 2 electrons and in the outermost shell it is having 5 electrons, 1, 2, 3, 4, 5. And same in case of neighboring atom of nitrogen. So what nitrogen will do? In order to complete its octet, nitrogen need 3 more electrons. Say nitrogen is having 5 electrons in its outermost shell and by gaining 3 more electrons it will complete its octet. And how nitrogen is managing these 3 electrons? Just by sharing from the neighboring atom. Now if I look at this figure, here the 5 electrons of nitrogens are mentioned and here in this the 5 electrons of nitrogen are mentioned. So nitrogen will share the 3 electrons of the neighboring atom and this nitrogen will also share 3 electrons of its neighboring atom. So what is forming? Nitrogen is sharing 3 electrons in order to complete its octet. And here also nitrogen is sharing 3 electrons. So 1 bond, 2 bond and 3 bond. So triple bonds are formed in case of nitrogen by covalent bond, which is by the sharing of electrons. Each nitrogen atom is sharing 3 electrons from the neighboring atom. So by that way, nitrogen is forming triple bond. Now, let's move to our next slide. Here, we are going to discuss allotropes of carbon. This is the very important concept. Now, firstly, what are allotropes? The various physical forms in which an element can exist are called allotropes of an element. Simply, an element is existing in various physical forms. Those forms are called allotropes of that element. Here we are discussing our carbon atom, and in case of carbon we are having three allotropes. The first one is diamond, the next one is graphite, and the another one is Buckminster fullerene. These are the three allotropes of carbon. Now we are going to discuss in detail about the three allotropes of carbon. Now we are going to discuss properties of diamond. The first property is each carbon atom is linked to 4 other carbon atoms by strong covalent bond. It means if I talk about carbon, then in case of diamond, the carbon is forming all the 4 bonds with other carbon atom. So carbon is forming covalent bond with other carbon atoms. This is the first property of diamond. If I talk about second property of diamond, here it is about the arrangement. Carbon is having tetrahedral arrangement in case of diamond. Say, if I talk about the structure, here central carbon is attached with 4 other carbons by the mean of covalent bond, and the arrangement of structure is tetrahedral. This is our central carbon. This is the first one, second one, third one, and the fourth one. So all the atoms are arranged tetrahedrally in case of carbon atom in our diamond. Now let's talk about the next property. In next property, the arrangement of carbon atoms in diamond is 3-dimensional. It means the diamond is a 3-dimensional structure. The fourth property is no free electrons. If I talk about diamond, then in case of diamond, there is no free electron. As we have discussed, say this is our carbon atom. It is linked with other 4 carbon atoms. So all the electrons are occupied. All the electrons are used in the formation of bond with another carbon atom. So there is no free electron in case of diamond. Now, if there is no free electrons, then there will be no conduction of electricity, because we know that for the conduction of electricity there should be some electrons, and in case of diamond all the electrons are occupied. All the electrons are used in forming the bond. So there is no free electrons, and if there is no free electrons, then there is no conduction. So diamond is non-conductor of electricity. The next point is high melting point. As we have discussed, the carbon is forming covalent bond, and all the covalent bonds are strong, that is formed between one carbon atom to another carbon atom. So because of strong covalent bond, the melting point of diamond is very high. So to melt a diamond, it requires a lot of energy. The next point is high density. In case of diamond, the density is high. How the density is high? We have just talked that each carbon atom is linked to another carbon atoms. All the 4 bonds are used to make bond with the another carbon atom. So that enhances the density of our diamond. The next property is hard and rigid. We know that diamond is very hard. If we try to compress the diamond, it is not easy to compress the diamond because the diamond is very rigid. Every carbon is attached to another carbons. So because of that, it is very difficult to press diamond. So diamond is a hard and rigid. Now let's move to our next slide. In our next slide, we are going to discuss the properties of graphite. And we know that graphite is also allotrope of carbon. Now, in case of graphite, the first property is each carbon atom is linked to 3 other carbon atoms by strong covalent bond to form flat hexagonal rings. Here we are having 2 main points. The first point is carbon is attached to 3 other carbons. The second point is it is forming strong covalent bond due to which a hexagonal ring is formed. Say this is the structure of graphite and this is the hexagon. What is hexagon? Where there is involvement of 6 carbon. When our 6 carbons are arranged in that pattern and each carbon is linked with 3 another carbon. Say this is our central carbon, it will be linked with another 3 carbons. Say this is our central carbon, so it is linked with 1, 2 and 3. So each carbon is linked with 3 another carbons in case of graphite, and every bond is the covalent bond, the strong covalent bond. The next property is the various layers of carbon atom are held together by weak van der Waals forces. This is also a star point. Say this is the one layer of our graphite. This is the another layer. So how the one layer is connected with the another layer? These are connected by mean of van der Waals forces of attraction. So in case of diamond, along with covalent bond, there is van der Waals forces. And as we know that van der Waals forces are weak forces, so because of van der Waals forces, the one layer of carbon is able to slip over the another layer. The next point is carbon is the soft substance. We have just discussed that in case of diamond, the one layer is able to slip over the another layer. So what it indicates? It indicates if we try to push the graphite, then there may be some movement, which indicates the substance is soft. The next point is presence of free electrons. If we compare graphite with diamond, we said that the diamond was non-conductor and the graphite is conductor. And we have also discussed that there is a requirement of free electrons. So it means in case of graphite, there is a free electron, due to which the conduction is possible. Here, each carbon is linked with 3 another carbons. It means carbon is having 1 free electron, and this free electron will be responsible for the conduction of electricity. If I talk about this carbon, this will also connect it to 3 carbons, and still this carbon is also having a free electron. So in case of graphite, each carbon has 1 electron, and this free electron is responsible for the conduction of electricity. So we can say that graphite is a good conductor of electricity. Okay, if I want to explain the conduction, if you take example of remote at your home, in the remote system we are having 2 slots for the cell, and if you insert one cell and in place of another cell you have to put the pencil. How? You need to sharp the pencil from both of the end and put it on the empty slot. What will happen? If you try to use your remote, it will work. What it indicates? It indicates there is a conduction of electrons through the graphite. We know that in our pencil, the lead is made up of the graphite. So by that activity, you can keep in mind that graphite is a conductor of electricity. The next property of graphite is high melting point. Graphite has high melting point, just as we discussed in the case of diamond. What is the reason behind that? The reason is same, the presence of covalent bond. And we know that the covalent bond are the stronger one. So just because of the presence of the covalent bond, the graphite is having high melting point. Now let's move to our next slide. Here we are going to discuss the properties of Buckminster fullerene. Fullerene is our third allotrope of carbon. The first property is fullerene contains clusters of 60 carbon joined together to form a spherical molecule. So, how many carbons are involved? There are 60 carbons involved in one molecule of fullerene. Next, if I talk about the shape of molecule, the shape of fullerene resembles with the shape of football. Just like football, it is having different hexagon rings and pentagon rings. The next point is fullerene have 20 hexagonal rings. In fullerene, we can notice in fullerene, we can notice 20 hexagonal rings. And if I talk about the pentagonal rings, fullerene is having 12 pentagonal rings. In pentagonal rings, This is our pentagonal ring. Now, if I talk about the next property, fullerene is neither hard nor soft. This property of fullerene is different from diamond and from graphite because the fullerene is having intermediate level of hardness and softness. So this is all about the properties of fullerene, which is the third allotrope of our carbon. Now, this is the very important topic. The topic is versatile nature of carbon. Why carbon form large number of organic compounds? If I talk about carbon, carbon has a unique property. It can form number of compounds, number of organic compounds. Now, what is the reason behind that? Why carbon has that ability to form so many organic compounds? Let's discuss about that. The first thing is catenation. What is catenation? Catenation is the self-linking property in which one carbon atom is linked with the another carbon atom and one carbon atom is linked with the number of carbon atoms as per its valency. Now, if I talk about the definition of catenation, what is catenation? The property of carbon element due to which its atoms can join with one another to form a long carbon chain. That is called catenation. Now, we are having three kinds of chain that is formed by catenation. The first one is straight chain. The second one is branch chain. And the third one is closed ring or ring type chain. Now, what is that? If I talk about straight chain, in case of straight chain, all the carbon atoms are linked in a straight fashion. This is the straight chain of carbon atom where number of carbon atoms are linked with each other and they are completing their valency. Now, if I talk about branch chain, what happens in case of branch chain? In case of branch chain, say this is the carbon is forming a branch. Say this is our straight chain and this will be part of our branch structure. So carbon here is forming a branch. It can form branch anywhere or any of the way, say here, here. This will also included in our branch structure. So this is the branch chain structure. And the third one is closed chain or ring type. Now, what is this? This is the example of ring type, or we can also say it cyclic chain. Here, the carbon atoms are forming a ring. Say this is one carbon atom. It is forming ring. So this is the ring structure of a carbon atom. Now, because of that, because of self-linking property, carbon is able to form a number of organic compounds. Carbon is forming straight, branch or closed chain. Now, we are going to discuss some important points. The first one is no other element exhibit the property of catenation to the extent seen in the case of carbon compounds. It means there is no other element except carbon which show the properties of catenation, because carbon is forming number of bond with another carbon atoms just because of the property of catenation. The second point is silicon forms compound with hydrogen with chain up to 7 or 8 atoms, but these compounds are very reactive. It means silicon also have property to show catenation, but not at the same extent that is shown by carbon. Silicon can form maximum of 7 to 8 atoms in a ring. Say, this is a ring of the silicon and here are 1, 2, 3, 4 and 5 silicon atoms. This is a 5-membered ring. Silicon can form up to 8 atoms. Silicon can form a ring which are having 8 atoms, but not more than that. Why? The reason being silicon is less stable. The compounds which is formed by silicons are less stable as compared to that of the carbon. Why the compounds are less stable? Because the reactivity of these compounds are very high. And we know that if the reactivity is high, then the stability is low. And if the reactivity is low, then the stability will be high. The next point is the carbon-carbon bond is very strong and hence stable. We know that the carbon-carbon bonds are very strong because these are strong covalent bond, and if the bond are strong, then there is more stability. So if the stability is more, then the reactivity is comparatively less. So in case of carbon, the bonds are strong and hence stable. Now let's talk about the next property of our carbon, that is tetravalency. Tetravalency is what? Tetravalency is formation of 4 bonds. Here, due to large valency of 4, a carbon can form covalent bond with number of carbon atoms as well as with other atoms. So, carbon is having property to form bond with carbon atoms or with the other atoms. Atoms such as hydrogen, nitrogen, sulfur and chlorine. So, this point, the tetravalency is also responsible for the versatile nature of the carbon. So, this is all about our part 1 portion. Thank you.